All right, guys, there we got matrix operations, just the basic operations with matrices. Let's see how it looks. The first thing, addition and subtraction. One very important concept when you add and subtract matrices is this right here. They must have the same dimensions before you do it, which means the size must be the same. For example, this first one here is a 2 by 2. That one is called a 2 by 2. And by the way, matrix dimensions go by rows and columns. So you count how many rows it has going this way, then how many columns it has going that way. All right, so if you add them, all you do is you add straight across. Like you add those two numbers, you get 1. You add those two numbers, you get -3. You add these two entries, you get 6. You add those two entries, you get 5. And that's adding matrices. That's all there is to it. That's why they have to have the exact same dimensions, same size, so that you can do that. The second two is subtraction, the same way. Subtract straight across. 1 minus 1. 2 minus -1 is 3. -2 minus 1 is -3. 0 minus 3. -3 minus 2. And -1 minus 3. And that's all you do. So pretty easy addition and subtraction. Let's look at the next thing. There's something called a zero matrix. A zero matrix is when you have all the zeros in the whole matrix. That's the only numbers in there. It is known as the additive identity because if you were to add that to another matrix, like if you add to this matrix 1, 2, 3, 4, 5, 6, you would get the matrix 1, 2, 3, 4, 5, 6. You would get the exact same thing. That's why it's called the additive identity. Remember, a zero matrix, all the entries in it are all zeros. Scalar products. Scalar is when you put a number in front of a matrix. And also, a matrix is always named by a capital letter. Like here's matrix A, denoted as a capital letter A. So if I'm going to find out what 3A is, basically all you do is you multiply every entry in A by 3. So you get -9, 0, 12, 15. Again, operations very simple so far. So take advantage of this stuff. Very simple operations so far. Okay, some properties of scalar multiplication and matrix multiplication. Commutative of addition works. Commutative of multiplication does not work. Associative of addition works. Associative of scalars work. Distributive of scalars work. Adding additive identity, you can add zero matrix, you get the same matrix. And there's also an inverse matrix where if you change all the signs in a matrix and add it to the other matrix, you get 0. So those are the properties that are true with real numbers that are also true with matrices, but not everything was true, and you're about to see which one was it. And it's this one, matrix multiplication. Probably the toughest, not that it's hard to be the toughest thing we're doing today because the other stuff was really easy. But you got to think a little bit on this one. If you're going to multiply an M by N matrix and an N by P matrix, what must be true is their middle dimensions must be the same. If those two numbers are not the same, you're not allowed to do it. So those matrices must have the same dimensions there. The outside ones, the M and the P, that tells you what kind of answer you're going to get. So if you multiply matrix A times matrix B, you're going to get an M by P matrix. And you can only do it again if the two middle dimensions are the same. It says, note, we can multiply two matrices only when the number of columns in the first is equal to the number of rows in the second. Okay, that means that's why the two middle ones are the same. And multiplication of matrices is generally not commutative. AB does not usually equal BA. That's one property of real numbers that's not true with matrices. Most of the time, if you multiply one way, then multiply the other way, you do not get the same answer. A lot of times you can't even multiply both ways. So, okay, I'll put 3 matrices up here, and we're going to do the multiplication. The first one says do A times B. So first of all, you need to check the dimensions. Matrix A is a 2 by 3. Matrix B is a 3 by 2. You're allowed to do that because the 3's are the same. And also because the outside numbers are both 2's, you're going to get a 2 by 2. Good idea to put blanks in there to make sure you get the right size and get the numbers correct once you get in there. So here's how it works. Don't let me lose you here. It's going to look a little crazy when I do this, but you got this. So just hang on and go with me here. When I multiply, to get what number goes into the first blank, I'm going to multiply let me get this out. Okay, I'm going to multiply the first row of that one times the first column of that one, all the way across. So I'm saying 3 times 1 is 3, 1 times 3 is 3, and -1 times -2 is 2. I just multiplied straight across and down. Now I'm going to do the same thing with the second column. So I'm going to cross that first column again and down that second column, across, down. 3 times 6 is 18. 1 times negative 5 is negative 5. Notice I'm adding down here. Negative 1 times 4 is negative 4. You always add. All right, now I'm going to my bottom row, my second row. Second row, now I'm going to use the second row of this first one and the first column of the second one. Going straight across and down. So I'm going to go 2 times 1 is 2, 1 times 3, and negative 1 times, sorry, I've got the top row again, darn it. 2 times 1 is 2, 0 times 3 is 0, and 3 times negative 2 is negative 6. That goes there. And then the last thing I'm doing, I'm going to cross that row and down the second column. So I'm going 2 times 6, 0 times negative 5, and 3 times 4. And then once you do all your multiplication, you just add your numbers up. 3 plus 3 plus 2 is 8. 18 and negative, that's 9. That's negative 4, and that's 24. And there you have it. Pretty good process there, though, to do that one. Let's check the next one. Next one says B times C. I already know B is a 3 by 2. C is a 2 by 2. And because the 2's are the same, I'm good to go. And I'm going to get a 3 by 2 matrix. So I'm going to go ahead and draw that here. A 3 by 2 means 3 rows and 2 columns. So 1, 2, 3 rows and 2 columns. I'm going to go the same way. It's going to get messy here, but I'm going to go across and down. So B times C, I'm going to cross that row, down that column, across, down. It's going to look like 1 times 4 is 4, 6 times 1 is 6. That's all you do. Now, I'm still on the top row right here, but now I'm doing the second column. So I'm going to go across the top row, down the second column. 6 times 4 is 24. Sorry about that. It should be 1 times 6. 1 times 4 is 4. 6 times negative 6 is negative 36. Golly, I'm sorry about that. Now I'm using the second row, so I'm going to cross the second row, down the first column, then second row, down the second column. So 3 times 4 is 12. Negative 5 times 1 is negative 5. And then I'm going to do the same row, the second row, times the second column. 3 times negative 6 is negative 18. Negative 5 times 6 is 30. Now I'm ready for the third row. So I'm using the third row. I'm going down both columns. So negative 2 times 4 is negative 8. 4 times 1 is 4. And then the second column, negative 2 times negative 6 is 12. 4 times 2 is 8. And now I'm just going to add all those numbers up. So I get 10, negative 32, 7, 12, negative 4, and 20. Just adding those up. Whew, it's quite a bit of stuff. Okay, AC. I think you're going to like this one the best. A is a 2 by 3. C down here, where's C? C is a 2 by 2 because that's a 2 by 2 and that's a 2 by 3. If you notice, their middle dimensions are not the same. So you can't do it. So we're going to say NP. It is not possible. Can't even do it. That's a messy slide. I hope that made some sense. We'll work on these in class like we always do. All right, last thing. Write a matrix equation for the following system. And we're just going to write these, not going to solve them, just going to write them. And it looks like this. In the first matrix, we're going to put all of our coefficients, 4, 2, and negative 1, 9, 0, 1, 4, 5, negative 2. All I did is I took out the coefficients from that one. And I'm going to put times. In my second matrix, I'm going to put my variables, x, y, z. Those are my variables. I'm going to put an equal sign. My third matrix, I'm going to go 3, 5, 1. Those are the constants. And the cool thing is, I'm not going to